more people will join, I'm sure, in just a few minutes. But in the meantime, I want to get tell you what the fantastic webinar that's in store for you. As you all know, it is a very topical webinar on leveraging generative AI and MATLAB in engineering education by Dr. Will Greenwood, who is a principal education engineer at MathWorks in the Massachusetts area, where I spent many years. Dr. Will Greenwood is a principal education engineer at MathWorks. He supports programs and products in education marketing organizations relating to curriculum development, hardware connectivity, and generative AI. Prior to joining MathWorks, Will was an assistant professor of civil engineering at San Jose State University. Will received a PhD in civil engineering from the University of Michigan Ann Arbor, with specialization in geotechnical earthquake engineering. So thank you so much, Will, for taking the time to join us, and really appreciate it. And over to you.
Great, thank you so much. All right, so I'll get started now. Thank you so much for the kind introduction. I'll start with just a few comments about MathWorks as a company and a little bit about myself there. I've been using MATLAB since I was an undergraduate student, all the way up through. I used it quite a lot during my graduate studies, and then in research and teaching when I was at San Jose State University. And I joined MathWorks 5 years ago, and we were just chatting earlier about how much has changed in the past 5 years, particularly in teaching and learning. So that's quite exciting and also scary. MathWorks has an interesting position kind of being between industry and academia. So hopefully I can bring a little bit of that perspective as well. So I'll start talking about that a bit more, then generative AI in engineering education more generally. Then go into some examples of creating instructional content with our new MATLAB Copilot feature in MATLAB, and then implementing hands-on projects. I'm specifically going to look at a couple of examples with Arduino hardware. We're finding with a lot of our contacts a really nice way to get students more involved in their learning is to really lean into the hands-on projects. And then I'll share some more general resources for implementing this and managing generative AI in MATLAB-based courses. So MathWorks obviously is very deeply rooted in education. We have millions of users in academia, primarily students, of course, and many universities that are using our software and have unlimited access to that. But ultimately, MATLAB is a platform that's driven by industry usage. So there are over 100,000 different organizations that have access to MATLAB and Simulink and are using that for their product development. We support a lot of deep workflows in the automotive and aerospace industries, for example. And that's really an exciting thing for me. So the government organizations, the private organizations, and then I work with academic organizations primarily, but seeing all these things come together in really exciting projects is, I think that's the motivating piece for me. And if you don't know, we have offices all over the world, over 6,500 staff, and most of them, if not all, are using generative AI in one way or another. I'm using it now on a daily basis. Really surprising, actually, some days how much time I spend using it. And then I go home and I try not to use it more sometimes. But this is something, it's really been a fast uptake of AI with generative AI becoming available. So a lot of our commercial customers are designing and developing engineered systems. And so these are systems that are interacting with their environment. They're performing certain operations. And AI broadly is changing how we interact with those systems and how those systems interact with us and how they interface with us. This has been happening for some time, but a bit slower. Now it's accelerating, and it's really shocking how AI is working its way into all stages of the engineering design process. And that could be fundamental research, that could be trying to decide if something is meeting design guidelines. Do we have defective batches in manufacturing? And then Predictive maintenance, for example, is a common implementation of AI. Now, when we're talking about generative AI, we're really thinking about large language models more specifically.
Are you sharing your slides, Will? Do you think you're sharing, or you want to share them yet?
Yes, I should have been sharing the slides this whole time.
No, it was not on. The sharing was not on, so you have to share it again.
All right, I will fix that.
Oh, now it's coming up. Yeah.
Okay.
Yeah, that's good. Let's keep going. Yeah.
All right. So I'll just continue from here. And so large language models, they are essentially stringing together text, trying to decide what is the most likely next word based on the context that they have. So most applications are generating text effectively. That could be code, or it could be just words in a document. They can do other things like classify text. So analyzing sentiment might be something that Amazon does with product reviews. You can summarize multiple documents and retrieve information. This is something I dream about I would have had, during doing literature reviews. Anything I discuss is really going to be focused on this text generation component. And that's also the thing that has been disruptive, extremely disruptive. So the access that students get to this is really what's caused a lot of difficulties. Now, there's nothing really new, right, about disruptions in education. So we've had things like calculators in the internet, but the speed to which students have gained access to generative AI and its ability to produce something that they could plausibly call their own has made this just a very abrupt disruption. Now, I will say all of these things, we've become more productive. These are all positive things over time. We should consider them that way. So things often feel painful at first, but we'll see where they go in the future. And I will say on a personal note, MATLAB Copilot itself, this has completely changed how I use MATLAB. I'm having more fun using MATLAB than I have in years. So now I'll talk more about practical applications for generative AI in education. So really anyone at a university is a potential user of generative AI. I'm focused more thinking about educators and students as well, but there's plenty of applications, of course, for researchers. And this is sort of just a list of high-level things that we were first thinking about. Okay, what could I do? What could students do? What could researchers do? What would be the value add if they had access to generative AI? But we can get a bit more specific. And so if we think more about students and educators that are having difficulty, I've had conversations with educators. Some are having a lot of trouble, and some are a lot more excited, and they're starting to embrace the technology and using it with their students. The pattern that I'm seeing is that large introductory courses that have novice students are having the most difficulty, right? So why is this the case? Well, subject matter is fundamental in these courses. It's not complex for AI. If the materials from these courses have been posted online for years, this is going to be essentially bread and butter for the AI to understand and handle. And the students that are involved in the courses, they haven't established their baseline skills yet. So they don't really know what they're doing. They haven't learned how to tie their shoes, essentially. And teaching methods that are more resilient to generative AI may be difficult to scale in the large courses. So a common reaction that I will come across is, well, we're going to try eliminating generative AI completely. I think that's very difficult to do. I don't really recommend trying to do that. I think it's more important to try and assess our courses, how we're teaching, make it more resilient, and really think about what are we trying to do? What do we want the students to learn? And let's focus on that. So my recommendation to anyone that is maybe struggling with this is to analyze your course, update all of your learning objectives, make sure that they're relevant. Ensure all assignments support the learning objectives. So if there are courses at a university that haven't changed much over a long period of time, this might be the thing that needs to push them forward. And then talk to your peers. That's what we're here for at MathWorks. We have a lot of folks like myself who are from academia and have experience teaching. We're always happy to work with you. And then, of course, modifying assessments. Well, let's make sure we're actually measuring learning outcomes. And I can give a bit more information on the industry perspective here. And the recommendation I have is to focus on AI literacy and responsible use. So what do I mean by that? That's validation of output and making it your own. So this goes for anyone that's using generative AI. Whenever it spits something out, we need to validate that, make sure it makes sense, and then also change it. We never use it as is. This is how we do things internally, say at MathWorks, or how I use it. I always want to make sure that what I'm putting out is actually my own and I can back it up. Then the protection of customer and company data. This is something that I think is important for students to understand. So when they're coming through their degree program, that when they leave and they go to a company and they start working as an engineer, they need to pay attention to what data they're using and what they may be allowed to do with that data. They also may be working on a project with a customer that they're not allowed to use generative AI. There may be AI may be forbidden being used in this application. So they still need to know how to do things. And then there's also the fact that they need to have the fundamental knowledge still. So they need to stick to their engineering fundamentals. They need to know the background. They're not going to be able to use ChatGPT to design a car without understanding all the basics. I'm certainly not getting in that car. I will tell you that. So I will say this might be the most important thing that I say. Maybe this was all I needed to say, but AI literacy is now a fundamental skill for engineering and science students. And it's a fundamental skill here at MathWorks. So there's some internal efforts. I'm involved in some of them, but developing workshops to help boost AI literacy for everyone at the company. So now if we think more about MATLAB itself and the software, there's several different ways that generative AI and MATLAB interact and work together. So first on the list, and I will show some examples of this, is MATLAB Copilot, which if you've used MATLAB Online or either of the last two releases of MATLAB, you have experienced this. This is applicable to any MATLAB user. We also have others, so MATLAB GPT. So if you are a ChatGPT user, you like the OpenAI environment, you're there a lot, you should take a look at this MATLAB GPT. That will give you a MATLAB specific experience, essentially, in ChatGPT. And then the next two are repositories that we've released on GitHub that are available to anyone. One is APIs for accessing LLMs in MATLAB. So if there's an LLM you want to use and you want MATLAB to work with that, you can certainly do that. And then more recently, the MATLAB Model Context Protocol core server. So if you're an extremely advanced user of generative AI and you want MATLAB as part of an agentic AI workflow, that's something that you can use as well. But we're really going to stick with the top level here, very high level. This is something that could be useful to any MATLAB user. So MATLAB Copilot, a few more details about that. So it's not just a chat interface within MATLAB. So this is something that is based on our documentation. It can run and assess code. It's been tuned for engineers and their workflows. MATLAB Copilot does require an internet connection. If there's no internet connection, it will be turned off or it won't work. Again, it can be used in either desktop MATLAB or MATLAB Online. And I do want to make a note that we don't keep the data that goes in. So any data you input is just used to fulfill your requests, and there's no storage. The chats do not persist through when you return to your MATLAB session. So there's more information about that on our website, and I'm happy to discuss that more. So if we look a bit closer at different ways to interact with MATLAB Copilot, I mentioned it's not just the chat panel here, but this is sort of the most interactive piece where you can have the conversation back and forth. There's Copilot in the editor and the command window as well. I'll show a quick video of that. And then there are these things called Copilot actions. So this could be something where you want to ask Copilot to do something in line. You could generate a test. You can ask it to explain code. So I could highlight a block of code as you see here in the screenshot and have it explain something, which is quite useful. You generate comments. And then, of course, you can make changes to whether you want it to make auto-completion recommendations, or you want to turn it off completely. So let's take a look at the Copilot in the editor. So here we can ask it to create a figure with 4 different plots. We've got some data you can see above that's being used for the plotting. It generates the code for those plots, and we get to look at it here. Might not be what I would want as a final product, right? But we can still make changes to that. And it's a nice way to get past what may not be the thing that you're trying to learn, are those pieces. And you want to focus on the data. You want students focused on learning about the battery applications and not specifically how to put axis labels on in MATLAB. So to summarize the different things that you can do with MATLAB Copilot: chat, generating, modifying code, explaining errors, which I think has the most value for students. And then I'll highlight the test creation again. If you're not using unit testing framework for MATLAB functions that you write, or this is something you can recommend to someone else, there's almost no reason not to do it now if you have access to MATLAB Copilot here. It's very easy to do. Now, to get the hang of all of these different ways to use MATLAB Copilot, I'm going to recommend a Coursera course that we've authored. It only takes about 3 hours to complete. This is something that anyone who might be using MATLAB Copilot, educators, students, researchers, they'll learn the basics. There's videos, readings, assignments, and then they can follow up with any of the other courses that our teams have produced on Coursera. All right, so if generative AI is being introduced to students, I think there are 3 things that they need to understand and get the hang of before they start using it a lot. One of those is prompting. So what are the best practices for creating their prompts? How is prompting different than just searching for something? What context is needed to improve the prompt? So this is really the important piece that will take you from I'm not getting what I want versus how I can add more context and really help this do something more useful. Refining and iterating. So do the results match what you expect? And how can you improve those? And so then analyzing results. Should you trust the generated results? Of course, with AI, the answer is always no to that, and we need to validate the output. And then how can you go about improving confidence in what you see and then actually make it something useful? So again, there are some things that MATLAB Copilot can provide that might be helpful for students. One is identifying the correct tools and functions for their application and what they're trying to do and how to approach a problem. Another is getting explanations of code. So if you've provided them with some complex code, they could use that to get an explanation, and then make improvements on their own, which would be an approach that I might recommend. They're also able to focus less on MATLAB syntax and more on they let MATLAB Copilot handle that implementation, and they can really focus on what the subject matter is. All right, so let's look at some ways that we can integrate generative AI for student learning. So if students are using this and have access to it, I'm going to say I've got a list of 10 things that I think are potential beneficial uses that we should be considering. One is just becoming generally familiar with.
I think we lost your presentation again, I think.
Oh, really? Okay. It says I'm sharing.
I can see it.
I can see it. Okay. Okay, fine. Go ahead. Keep going.
All right. Okay. I reset it, so it should be back and good. All right. So AI literacy exercises. So if I recommended that AI literacy is an engineering fundamental, that's definitely something we can use this for here. Documentation and commenting of code, guiding through data visualization, and working on their technical communication, debugging, and I'll show an example of that in a minute. Explaining how code behaves in plain language, natural language. Getting starter code for complex problems. So if we want to increase the complexity of what they're doing, we can give them a starting point there. And then scenario-based problem solving, of course. And then as we get into things that are more advanced, algorithmic exploration in MATLAB, and then performance optimization for some of their projects. This might be really interesting in a capstone project. So I'm working on a detailed guide of how to actually implement these in a useful way in different courses, and I'm happy to work with you on that and try to tailor something that's specific to your situation. So let's take a look at debugging assistance, just as one example. So students can use Copilot. They can to identify syntax errors. It can suggest fixes, explain why certain changes are will improve performance or accuracy. And one way to implement that is to assign students a partially buggy MATLAB script. So this is something like find where the error is in this script, and have them use Copilot to identify the errors and propose fixes. So this would show them an appropriate way to use generative AI as part of the debugging process. Then I would add in a reflection section. So explain why Copilot suggested these changes and whether you agree or not. And so the outcome of this should be that students are learning some of that debugging logic. They're also getting used to evaluating the AI suggestions critically so that they are not just going to take it for its word. Now I can turn this into a prompt actually to use myself in MATLAB Copilot. So I can say, create an assignment for whatever my course is. It assigns the students a buggy script as was defined on the slide here. The learning outcome for this assignment is to apply their debugging skills and evaluate AI suggestions critically. And so if I build that prompt out like this, the bold pieces are where I've inserted the bits from the last slide, I can get some interesting results. And so MATLAB Copilot's not just giving me code that does something, it's actually giving me an outline for how I may want to think about building an assignment for our students to have generative AI, but also actually do something useful and focus on learning. So it does a few things here. It provides materials, it suggests instructions. This is not exactly how I might do it, right? But this is a really nice starting point, and it does a good job giving me some new ideas. And then, of course, it gives code as well that I can use as a baseline with bugs in it, and I can change what those are. I can remove more pieces. The comments here are really identifying what those are and explaining it. So I could ask it to make it a bit more complicated. And it gave me more pieces too here. So it gave me instructor notes, a list of what the intended bugs were and descriptions of those bugs, the corrected code, an assessment checklist. I don't know if I want to use its assessment checklist, but that's a nice thing to get me thinking about different things that I can do. And then a note that I can provide students about how they should be using this appropriately. So another one of those examples I provided was explaining code behavior. So Copilot can, of course, explain unfamiliar functions and scripts to students. And then they can use these explanations to ideally deepen their conceptual understanding of the topic. So I would implement this by assigning what should be unfamiliar MATLAB functions and ask students to use Copilot to have it explained to them. Then they need to write their own summary, provide an example application of that function. So the outcome here is they're going to hopefully build some conceptual understanding and also their technical communication skills. And again, in really all of these cases, they should be thinking critically about what the AI is providing to them. And then again, on the AI literacy, I think this is a good thing to think about in all assignments at this point. Include lots of reflective tasks about how did Copilot suggestions influence the solution? What biases or limitations did you notice? So this should help them build up awareness of what some of the limitations are of AI in engineering. And this is an important career skill, I think, and it's only going to become more and more important. So how might you implement this? Well, lots of reflection questions in different assignments. If Copilot was used, how did this influence your solution? Did you notice any limitations? What did you have to do to get to your solution? And then discussions of ethical and professional implications of AI use in engineering courses. So the outcome here is, again, hopefully they continue to develop awareness of what AI's role is, any biases it may have, and limitations, and how they can overcome those. So let's look at another example of how I might use MATLAB Copilot to support instructional content and assessments as well. So I can take a course that I had been teaching. I can take some of the learning objectives, and I can use that to write some prompts that might give me some new ideas for how to support student learning. So I can take the learning objective and I can ask MATLAB Copilot for its opinion on that and ask it to help me improve that. Then I can also put that into a prompt. So let's say I have first-year engineering students, and I want them to be able to write MATLAB code that uses if, else, and while loops, right? They are only given a problem statement, and they need to produce correct code for certain test cases. So I can take that, a refined learning objective essentially, and put that into a prompt. And I'm going to format that prompt in a specific way. So that's with a format, what format I want, make reference to something. So this would be the learning objective, what I want Copilot to do. So a very simple function that just converts temperature from Fahrenheit to Celsius. And then the framing, which is what I really want it to do that's going to make this applicable to my teaching. So I will ask Copilot to do this for me, and it will give me a structure for the assignment, which is quite interesting. Of course, this is extremely simple. It gives the function here, and I can change this however I want to be the starter code potentially for a student. Now, an alternative to this is, let's say I don't actually want the student to use Copilot at all to do this, right? So I want to give them a situation where they may not have that. So the alternative would be to I'm going to ask Copilot to make a MATLAB Grader assignment. So MATLAB Copilot is fully aware of MATLAB Grader. In MATLAB Grader, students don't have access to MATLAB Copilot. So whether that's the Grader online environment, or if they're using, they've opened the MATLAB Grader problem in MATLAB Online, they won't have access to MATLAB Copilot. So that might be the case where I want them to actually do a bit more of this code writing themselves for the function. Now, let's talk a little bit about hands-on projects. So I mentioned earlier that educators that are kind of struggling with students being more engaged. I had someone come up to me at a conference and say, really the problem I'm having is that they don't care so much. They're not engaged with the learning material. So if they think that I can just generate something to get the answer, then what's the point? I don't really need to learn things. And so what worked for this professor was to think about more hands-on projects and have students learn about sensors and actually go around using them and collecting data. So MATLAB Copilot is not just aware of things like MATLAB Grader, it's really aware of anything in MATLAB, so all features and capabilities that are in our documentation. So one of those things would be our support packages for Arduino hardware. So both MATLAB and Simulink support is included by us. MATLAB Copilot, of course, is going to be focused on the MATLAB implementations here. So again, you can either connect the Arduino directly, communicate with MATLAB. You can also generate code through through Simulink if you want to pull something. I actually have I forgot to put it away, but I have it on my desk here. And then more recently, you can actually communicate with an Arduino through MATLAB Online, which is really nice. So for the first example here, what I'll do is create a simple IoT project. So I will put together a prompt that says that I'm creating an assignment, and it's in this introductory engineering course. I have an Arduino Uno on my desk, and it's connected to MATLAB. I want students to communicate with the Arduino and wire a circuit with two buttons. One button switches an LED on and off, and the second sends the status of the LED to a ThingSpeak channel. ThingSpeak is our IoT platform. In this case, I would have them build a dashboard in ThingSpeak that is showing the status of the LED. I want Copilot to provide me a list of the required components and instructions for how to go about wiring the circuit. I want the MATLAB code and an explanation of the MATLAB code. Then I will make the changes that I want. So it'll put together a problem description here, and it shows everything that's needed. There might be some mistakes in the wiring instructions, so I'm definitely going to be looking closely at that. I may say, actually, I don't want to provide wiring instructions in this level of detail. I'm going to make some changes there. And then the MATLAB code itself, I've broken this down into different sections for how to communicate with the Arduino, and then how to read and write from a ThingSpeak channel. And if I don't know myself all the details of the implementation of MATLAB's Arduino support and how it's able to communicate with a ThingSpeak channel, I can have Copilot help me out with that so I can learn about that and build something that's interactive for my students. Now, we can consider another example. So let's say I want students to collect acceleration data from an accelerometer. That's actually what I have connected to my Arduino right now as an IMU. So I can ask it for I could ask Copilot for the code. I didn't ask it for this code. I wrote this myself, but I can walk through for students how to connect to the Arduino, how to configure the pins. I can decide what they should be doing themselves. And then I can use Copilot maybe to provide suggestions. So I didn't have this in my code originally, and it had put this in about checking the calibration of the sensor and providing messages about that, which I thought was actually quite useful. Then the next thing in the project would, or the assignment would be to read what is the XYZ acceleration at this point in time. This one's making me think that my desk is crooked, so I'll have to look at that. And then we can go into real-time plotting. So I can, again, decide how much I want to provide to my students and what I want them to focus on. Do I want to give them this code and then have them work with something in real time? And they can actually get hands-on. They can pick up the accelerometer and tilt it and start to understand what these different acceleration readings are when they're holding the device. I also work with a team at MathWorks. That's part of our training organization that creates courseware. I think we have some folks on the phone actually that have some courseware related to hardware projects. But this is an example. This is an introduction to engineering with Arduino example where it also has IoT and some interesting projects that students can wire and actually work with hands-on, rather than relying on generative AI. So some additional resources beyond that. I mentioned earlier the Coursera course on MATLAB Copilot. It's about 3 hours long. This is something that anyone at the university could take that may be using MATLAB, so they can see how that works and really understand what the implementation is. The other thing that I think may provide some value are our learning paths. So there's a very long list here, but these would be things that are you could assign to students that they need to work through, submit a certificate when they complete. This can either be integrated in a learning management system or accessed on our website. And then, of course, I mentioned MATLAB Grader. So I saw there's a question in the chat about how to turn MATLAB Copilot off, which can be done through the settings of MATLAB Copilot. But also, if you want to give a student a MATLAB coding assignment, essentially that's not going to have Copilot write code for them. This is what you would use is MATLAB Grader. And so MATLAB Grader can either be used on our website or integrated in a learning management system. Another thing is I mentioned a lot of interesting project ideas, hardware projects, things that are more industry aligned. I would recommend checking out the MathWorks challenge projects, which are on, there's a variety of them on GitHub. There's also a page on our website. These are things that would be really interesting to students, and I think would get them more involved in what they're working on. Okay, so just to wrap things up, I'd love to have more discussion about the impact of generative AI in universities, what's working, what's not, and then what resources do you want to see from me? So I'm actively working on resources that we can provide to educators, to students. What are the things that I should be focused on so that I can provide to be a better assistant? So also, anyone can reach out to me at any time. I'm happy to help with any specific cases in courses at your universities. So I imagine that we will have some questions. I'm happy to go back to any point in my slides. Apparently, I still have my Arduino on my desktop as well. So thank you all so much for joining.
Thank you. Well, that was very, very useful, informative, and now we are open for discussion. So just raise your hand or unmute yourself and chat. Put some chat in the chat box. Whatever you want to do.
Sir, am I audible?
Yeah, Archana, go ahead. Yeah.
Hi, sir. Sir, does Copilot support Simulink models?
So Copilot will specifically avoid talking about Simulink, but you will have something for Simulink fairly soon. So that will be coming up in the next few months. So we'll definitely get you more information about that.
Sure, sir. Thank you, sir.
Okay, question from Megha. She says, can you please provide a typical example where students enhance understanding about limitations of the Copilot?
Sure. So I mentioned a few times about how when you get output from the generative AI, that it needs to be validated, right? So I can, even if I ask students, I say I'm not giving them a script that I know has bugs in it or was generated to have bugs, there will be mistakes. It's very likely there's going to be something that's not right. The implementation is a bit off for the situation. So when students can look at that and see what it is, and then identify how to fix it or how to ask for help to fix it, that would be the case of where their understanding of the limitations can be increased. The other is, well, there was just a question about Simulink, right? So it can't do everything. So they definitely, you can also experiment with it to identify what I would want to ask it to look at. One of those was the wiring, right? So when I asked it to wire a circuit for doing X, Y, or Z, it's not going to do it correctly. It's very unlikely.
Yeah, question from Ranjita. How can generative AI simplify the creation of MATLAB-based assignments?
Yeah, so I think the way that it simplifies things is to, one is to really get there, I would have good prompts. So I showed the structure of some prompts earlier, and you'll see these in the slides when you receive them. that's to ask it to structure the assignment a certain way, give it a description of what's in your course, what you want your students to learn, and it will help put together the pieces. You can also ask it to try to make your assignment more interactive. So this is something that I was doing earlier today, and it created basically an update to something that I had been working on with my Arduino and the IMU on it, and was walking students through, and they had in the command window that they had to go. It told them, okay, well, you need to check this. You need to disconnect the Arduino. You need to disconnect the sensors, reconnect the sensors. And so it gave me a lot of ideas for things that I wasn't necessarily thinking about. And then the other factor is you could generate the MATLAB grader assignments with it because of its awareness there, and that can speed up the development time for those.
Okay, next question has to do with ethics. How can educators balance the integration of generative AI tools like MATLAB Copilot with maintaining rigorous academic integrity standards, particularly in project-based assessment?
Yeah, that's a major challenge, right? So I think this would probably depend significantly on what you consider to be, what you define as how you want the appropriate use and how you want students to use it. I'm not in a position to be able to stop students from doing a particular thing, right? I suppose that maybe that's part of the reason I'm not in academia anymore, right? But I do have experience dealing with academic integrity situations, and it's not my favorite thing. So this is like the existential question, right? This is the major challenge that we have to deal with, is how do we keep this rigorous? I think upping the difficulty is the way to go. And ultimately, what is the rigorous academic piece? What do we want them to learn? If it's about writing code in MATLAB, maybe that's not something that's rigorous anymore, right? So I do still think that in project-based assessments are in a better position when students need to build something and actually put something together and explain it, and rather than exams.
Yep. Okay, next, another question from Megha. I suppose Copilot may generate a code which may be beyond the scope of our license. Am I right?
If you are on, so I don't think it will know exactly what your license situation is, but if you're on our campus-wide platform, that shouldn't be an issue because you will have access to everything. And I can check on that situation if you share your university. I can certainly follow it there.
Okay, another question is here. In your experience, what pedagogical frameworks or strategies are most effective for embedding generative AI into engineering curricula without diminishing students' foundational problem-solving skills?
So I would continue to lean into project-based learning. So something where they have a significant project, they need to build something and have explanations with it, work with something hands-on, and also work with others in a team that will help them develop those skills. I also would focus on giving them something that they start with rather than a blank slate. So the blank slate where you say, okay, here's the situation, you need to do X, Y, Z, write the code for this. That is set up perfectly for them to put into AI and get something out that works. You give them something that is not complete, they have to think a little bit more. They need to look at all the components. So that's the approach that I would try to take.
Okay, another question I would also like to know if Copilot can optimize my existing MATLAB code.
Yes, it can. So you can ask it to how you could improve your code. How can I make this faster? One thing you can do is in your script, highlight some of the code, right click, then say ask Copilot, and say, hey, I'm trying to make this faster. Say whatever you're trying to improve. then it will have a window will pop up and you can view the diff of its suggestions and what you had and see what the changes were. You don't have to accept all the changes. You can then get explanations of why it was suggesting those changes. That's one of my favorite applications for this. I'm doing that with my code.
Great. We had a lot of questions there, and you did a great job responding to them. Will there be any data privacy issues addressed? I guess you might have talked about.
Yeah, I mentioned it. I mentioned that earlier a little bit. So when you are using MATLAB Copilot, we don't retain your conversation. The only way we would have it is if you sent it to us, for example. It's not conserved between MATLAB sessions. If I go to MATLAB Online, I'm not going to see my same conversation. So we specifically do not want that data. We're not so we don't have that data. We don't use it to train any models. That's something that is the case with us. It's not going to be the case with everyone else that you're using. And that's a decision that's based on us not wanting to have student data. We don't want the data. We don't want to be responsible. But then also commercial customers as well. There may be IP considerations.
Well, okay, great question. And the response to Alfred's question, the recording will be available. Presentation, you might have to email Will himself. His email ID is on the screen. If you would like the presentation, just email him. He might be happy to send it to you. Okay, thanks everybody. And before I give it to Hans, I want to acknowledge Tanya, who's been here patiently part of the webinar. Over to you, Hans.
Thank you very much. You're reading my mind, dear Krishna. I was just going to welcome Tanya, our incoming IFEES president from Brazil, who has joined us here. And I'm very delighted that she's with us here. And we value her leadership very much. But also, I'm very happy, and I've mentioned this at the beginning, that PJ Boardman, a key partner, member of our global IFEES GEDC.
There she is. She's here. She's with us.
Wonderful.
Hi,
yeah, perhaps PJ wants to say something because we value her personal and intellectual professional contribution to our community, and she facilitated Will's participation today. PJ, I want you to know that, okay? I don't know if you want to make a comment, but I just want you to know I was very happy to see you, that you joined us. The only thing I want to say, this is an amazing topic, and as you said, Krishna, we will share the recording. We do this obviously diligently all the time.
PJ wants to say something. PJ wants to say something. Come in, PJ.
Oh, wonderful.
Can you hear me?
Yeah.
Yes.
Yeah, go ahead.
No, I just want to say, first of all, thank you for inviting us to present to you today. We just have a long history of partnership and collaboration with IFEES and GEDC, so we're grateful to be here. And just please let us know if you have follow-up questions. Will did a phenomenal job, but we consider this a real partnership. And so if we want to hear about your experiences and any questions you may have. That's it. Thank you, Hans and Krishna.
Oh, thank you very, very much, PJ. It's a pleasure. Basically, anybody else wants to make a comment? Okay, I see Tanya's comments per se. Obviously, thank you very, very much. Muito obrigado, Tanya. The only just final comments I want to make, I'm working very diligently with several leaders and friends, colleagues on our 20th anniversary of the founding of IFEES in Brazil, and we'll be celebrating that next year, and we're working on that diligently behind the scenes. And I'm working very closely with our hosts and partners, our forthcoming global conference in September next year. I just want to put this already on your radar screen in Cartagena, Colombia, where we had our global conference in 2013. I just wanted to mention this to all of you, and any questions you have, please don't hesitate to write to me and to us per se. Krishna, thanks very much for facilitating. Yep. And Will, you're a wonderful presenter. Thank you for your thoughtfulness. And again, PJ, thanks for facilitating. Okay, all peace be with all of you.
Thank you, everybody. Good night, good day, good evening, and be happy, everybody. Take care.
Absolutely.